Hi, in this video, I'd like to share some idea or intuitions why chemical equilibrium constant must be formed like that. Because since when I was young, I have these questions, and of course, my several students keep asking about these questions, and my friend, indeed, my girlfriend also asking these same questions. So I'd like to explain the chemical equilibrium constant with simple math. In order to understand the chemical reaction constant, we have to accept or we have to pre-understand two very basic concepts, which is chemical reaction is collision of element, and most importantly, it happened by chance. So we will see exactly same thing happen in this real world in the micro or nano world. All right, so let's see the equation constant K. Um, this is a general form of constant K with element A, B, C, D. And as we know, A, B, C, D must be certain number, which is molarity of the each element. All right. So my question was, and my student question was, is this in this equilibrium? Our reaction part is here is addition, but why we have to here multiplications? Why? And moreover, the constant of each element, which is a or let's say coefficient or let's say ratio of the reactions, the ratio of the reactions, y must be placed in exponent. Here, such like that. So that is a two question that we solve in this video. All right, so let's move the um, explanation part. So my simple explanation start with the the probability. But in order to that, let me introduce a simple model why this is happening with this basic model first. There is chemical A with B have react with chemical with C and D. Of course, C and D chemical react having product with A and B. So what does happen? There is present of chemical A and there must be B together. And then they collide each other. Then boom, there is some energy going forth. Um, and then the element C, element D have to come out. Sorry, D. Right. So this is the model of the forward. Okay. Then what is the other model? Yes. In the same time, chemical C and D present where is present, and somehow the chance they meet each other, and then there is some energy going forth, and then the chemical C and D, A and B is having a result of the chemical reaction of C and D. So that is chemical equilibrium what's happening. So this is a simple model, but we have to understand. So let's make more detail examples why this is happening. All right, so we will see here. Let's say there is some beaker and there is some solutions. which contain A and B. Of course, there is C and D. The majority probably water. Then I like to take some specific area or specific space here, and then I will see the chemical reactions. So let's zoom in this specific area. So it's placed by here. In order to, I'm interesting, the chemical reaction happen in this specific area. So that is my um, the real world, but micro, even nano world happening. So I like to see specific chemical reaction only in this specific area or space. Then what is the most important part? Yes, there must be element A must be present, and there must be element B must be present. And then they move by chance, such like this, and then A also move, but somehow, sometimes later, they collide each other, then boom, they happen. The chemical reaction happen. Yes. So now we having a model. Then let's see in mathematical way. So we will check this. Then probability of A. What is the chance that A present in this specific area? Yeah, it is simply say that I having a volume or a specific area. If I have, okay, let's say the number. So let me write down, let's say M or number. Okay, number, let's say capital N. Okay, I have a number, certain number of this overall number in these solutions, and then I looking at specific space, so I divide by N. Sorry, V space. So this is a probability that A present in this space. And then in chemistry, number of N, we can write down moles. Mole is a unit of the group of element. And V, just I like to write down V. Usually in scientific way, we write down the liter. So let me write liter. And however, what is this unit in the chemistry? Yes, that is a molarity. Let me write down M. So in mass, the probability the element A present in certain space, we write down Pa. But in chemistry, it represented by probably the molarity, the how many element placed in certain area. In the same way, present of B in mathematical term, we can write down P, and of course their unit is M. And this M, let's say this the molarity of A. So let me write down just A. And this is, let me write down, oh sorry, let me write down B. Yes. So now these two terms directly interpret the constant constant of element A and B. How many element in that space? Okay, and then there's another very important concept is we, in order to make a chemical reaction, we have to have this. Element A must be present in certain space with element B. In other words, the event of A must be occur with event with B. In these things, let me quickly introduce the independency or dependency of the reactions. But by intuitions, What do you think? Um, the element A, if present of element A really affect to the present of B, it is. In other words, let me make this example. This is map of Seoul. Since I live Seoul, I make an example. Um, and the person A living here, but it's really affect person B living there. In other words, person B know the information of person A, so make the living the part is here. Yeah, probably not. The In other words, the unknown person of me living the another side of liver doesn't affect doesn't affect the fact that I am I living in here, the northern part. So this is the idea of independency. Then let me make another example of independency. Let's say the raining and coin toss. Okay, so as we know, the coin toss, head or tail, is by chance of 50%. And then, of course, it is not, but let's say if there's a 50% of rain, so in so. Okay. And now question is, does these two events are independence or independence? And the answer must be independence, because if it is dependence, rain must be knows the informations of coin toss. So if there's a head, then more rain come. If there's tail, less rain come. But the reality is not, does not. And also the coin, if this is a dependence event, coin knows that happened by rains. If the rains come, more head occur. If no rains, more tail occur. No, it is not have such like this happen. So they are definitely independent. Then the question is, what is the chance that probability of head with rain? In other words, today I toss with coin one time and then it gives me head and same time it rains. Yes, it will be probability of 1.5 multiply with 1.5. So now we have the probability of independency. If certain event happen with independence, we have to multiply with 2 probability. And now we go back to our chemistry. We know that the element A present in the solution in certain place is probability A, and B is P. And then we want to have chemical reaction, so they must be happen in the same time, or let's say same space. What is the probability? Since they are independent, we have to multiply with these two. All right, we're almost done. So this is the mathematical term, and chemical terms, the occur happen, so it must be A times B for the four reactions, and same way the backward reaction must be C and D. So the multiplication we understood, now we understand that because of by chance they are independent, the present of A must be required and not required present of B. So they happen be together. So the chance that A and B happen is the chance of A itself by multiply by chance of B. Okay, now we are almost done. Then our next question is the property, sorry, coefficients. Okay, coefficient will be the more easier and simplest example. So let's say there is A times of chemical A, there's B times of B, and C ratio with C, and D coefficient with D. What is it means? The element of A must be required the number of A much. And element B also requires the number of B coefficient in order to make chemical reaction. In other words, if there's a smaller single number, does not occur the chemical reactions. By the way, I draw. So what does it mean compared to the previous example? This is more difficult to make a chemical reaction compared to the previous example because it requires more element being present and occurs forward. So let me quickly draw the example. In this time, I have in same small particular space, but the element must be require as much the coefficient say. So this is element A, and there is element B. And then now we have to think carefully. This single element B chance is probability of B. And then there's the next element which is probability of B. Yes, and these two are independent? Yes, they are independent. Whether it means that whether B1, let's say this is B1, element does not require any informations or does not require any being present for the element of B2. It doesn't matter whether B is there or not, B2 is there, element B having a still same chance to being present in this space. So in previous model, each single element we having just only two element multiplication because it requires only two elements. But now we have several elements require present. So let me rewrite in mathematical way. Probability of A happen with A happen with A until the element A require and element B happen with B happen until the element B require. So in the mathematical terms, we have to rewrite with each single probability A multiply A multiply A until B multiply probability of B. Then how many elements here? A much element. And since we know that each single term of repetition or multiplication, we write in the exponent. So finally, we have these properties. And of course, backward reaction, we have these properties in mathematical term. And instead of write down P, just write down the molarity or given number. We can make our original equations of the constant K. So this is the quick idea that why these equations coming from. So let me quickly summarize by word why why the multiplication happen, because the present of element A and present element of B they are independent. And second, Why the exponent? Why coefficient become an exponent? Because the present of each single element are their independence, and they are required to make chemical reactions forward or backward. So therefore, that much of the chemical need to react. So since they are independent, they have to multiply with the number of their coefficients. So the equation finally become like that. This is my first video. I hope it not. Yeah, I hope it may understand. You may understand of this equilibrium of constant. Thank you.